Okay, guys. This is just going to be a quick video on my wand remote reception and kind of just some findings that I've been having in testing it. So we have it hooked up to this guy, which is something new and exciting to be announced eventually. But, okay, so what are we doing here? What we're going to do is we're going to look at this remote with and without this metal case on. You'll notice that there's a bunch of metal sitting around. This is the PCB. This is the antenna. This sits inside of there. And then there's going to be, if you look, here we set that there, right? The antenna's there, and there is essentially an encirclement of metal around the antenna of their remote. So the only way that the radio is getting out is essentially in this direction and potentially through this screen, but I doubt that it's extremely RF transparent since it has conductive material inside of it. So my guess is it wouldn't be terribly RF transparent, but basically you can see that there's some shielding around the antenna. So what we're going to do is we're going to walk away from the remote. Okay, so what we're going to find is that the range that I'm walking away is much farther than when you're riding your skateboard. And so people might say, oh, well, that doesn't matter. The important thing to know here is what happens when I walk away from the receiver. What is the physical phenomenon causing the dropouts? It's an attenuated power in the receiver, okay? So what that means is that the signal gets weaker and weaker as I walk further away. It's very intuitive to understand. So what happens when, let's say, you were to place your receiver non-optimally in an enclosure with carbon fiber? What does it do? What does that having that conductive material near the antenna do? It attenuates the signal. So putting your receiver in a non-optimal location attenuates the signal in the same way that that walking away does. So you can think of it in the same way. Additionally, what about external RF interference? It's the same thing. Everything here that we're talking about has the same negative phenomenon. So walking away is a great way to simulate other sources of interference that could potentially cause a dropout on your board. So disregarding it and say, oh, well, you're only 1 meter from your board doesn't make sense. It's important to have a receiver that works pretty far from your board. You could do the math out to figure out exactly what that was based on the interference you're encountering, but it's a good rule of thumb that if your remote works from far away, it's probably going to work up close. Okay, so let's start with, let's do metal case on first, okay? So we can see. This wand has a really cool firmware in it, and it's got this little thing here with blinking lights to show you when it's connected. It's kind of hard to see on video, really easy to see in real life, so I'll be kind of commenting on when it's dropping out. An important thing I want to say here is if the connection's intermittent, then it's already unacceptable, right? So if it's dropping out kind of when I'm flipping around in different orientations, I would consider that completely useless as a skateboard remote because that's scary dangerous. So let's see how far away I can get with this remote before it starts dropping out. So I'm walking this way, which is worst case because it's putting my body between the remote and myself. And I'm walking, and right about here, I start getting dropouts, okay? So you can see the light is no longer blinking, and I'm probably not but 15 feet away. If I turn around, it kind of cuts back in. Depending on how I orient this remote, it starts dropping out again. It's kind of hard to see, but right about here, it's completely dropping out. And if I walk down over here, it only gets worse, and it just is dropping out constantly, essentially not working. So my remote right now, if I get more than, 15 feet from where that PCB is completely useless, and it's not in an enclosure. There's a little bit of metal here, I guess, but like, yeah, I mean, it's not much, is it? Like, yeah. So a wireless signal should easily be able to go around that, essentially. So yeah, it drops out, like it's dropping out right now. Now let's take this metal case off. Okay. Now, same thing. We're blinking back and forth. Everything looks great. We start walking away. I've got my body. I've got it close to my body. Everything is totally fine. This is working great. The remote is still getting really good reception. I can see that it's blinking back and forth. Everything's good. And I'm already probably twice the distance away that I was before. I can go over here. I can go out into my kitchen. It's still all working good. All of these places were completely non-receptive before. Okay, so that metal near the antenna is a bad design choice. It is making you more susceptible to interference. It is making you more susceptible to bad receiver placement. I don't cut out until I actually leave the front door of my apartment. And even then, I can still kind of, depending on where I position this thing, I can still get some reception back. So, yeah. I just don't understand it. There's a very simple solution to this. Here, let me close this door so my cat doesn't escape. But if you were to take this metal case, where did I set that dang thing? Ah, here it is. If you were to simply take this metal case, you cut it right about here, chop it off, and then replace it with some type of plastic or composite material, which is RF transparent, all of a sudden all that metal around the antenna is gone. You can still have your premium metal hand feel or whatever it is you want, and now the antenna is in a lot more exposed position without any metal around it. So, I mean, this is just, it's in any wireless module datasheet. Do not put metal near your antennas. Okay, guys? Public service announcement. And definitely don't do it in a product that you're releasing. It's not smart. Cheers.